How do you assign IPv6 addresses to our devices? Well, it depends on the device. We can assign addresses statically. We can assign addresses automatically. We can assign addresses dynamically. And then within those, we can allow some automation to happen as well. And depending on the device, will determine what is the better way to do it. For example, for our end stations, our clients, what's the best way to have them auto-configure their devices or their interfaces with IPv6 addresses? Well, hopefully in some automatic fashion or some dynamic fashion, using stateless auto-configuration or DHCPv6. But my routers, I want to make sure that those router interfaces, their addresses don't change. So statically assigning addresses on router interfaces is a better way to go. So on my router interfaces, I can allow the interface portion to be manually assigned, or I can have the interface portion auto-generate itself. So let's look at the two different options here for static assignment on our router interfaces. So here we're looking at the top example, interface Ethernet 0/0. We can see that it says IPv6 address 2001 DB8 2222 and then 7272. So right here, because of the fact that we have colons right there and not a double colon, these are the very first 4 fields. So the very first 64 bits in that particular address. So that right there is the network portion. So since the first 64 bits are already taken care of, the rest of this, the double colon 72, is referring to the interface portion. So I statically assign the entire address, including the network portion and the interface portion there. So that interface portion, if you're struggling with what double colon 72 means, this is all it means. If I break it out, make it bigger, we have 0000 colon 0000 colon 0000 colon 0072. That's what that means. That's all it means. So we've truncated that down so that way there it just appears as double colon 72. And then we specify what is the prefix we're dealing with here. So essentially, what is the mask, okay? Subnet mask, if you want to call it that from our IPv4 days. But we call that our prefix length. So how long is that prefix length? It's a /64. So that means these first 64 bits are really the network portion. That's really what that means. So you can statically assign all the router interfaces that way, or you can tell the router interfaces, this is your network portion and your prefix, and go ahead and auto-generate the interface portion of your address. So let's see that here. I'm going to clean this up just a bit for us. So down below here, we can see we have 2001 DB801 and then double colon /64. So here we have 4 fields, 4 successive fields we can see. And as a result of that, that is our network portion here. And we're dealing with a /64 prefix. Here it says just double colon. So what that means is 00000, all zeros. That's what that means. So I am not assigning that interface portion right now. So as a result of this configuration, I have to tell the router, automatically assign your interface portion. And our routers support EUI64 to accomplish this. So what is EUI64 all about? Well, EUI64 is all about taking a MAC address, which is how big again? It's only 48 bits, isn't it? 48 bits. And how big is the interface portion of an IPv6 address? Yeah, it's 64 bits, isn't it? So we have a discrepancy here of 16 bits. 16 total bits different. But every single Ethernet interface has what? It has a MAC address. So we can take our MAC address and we can add another 16 bits. And these are the 16 bits that we are going to add inside that MAC address. So open up the MAC address as you see here, slide in FFFE. Now, somebody once said to me, oh, you mean we're filling the field with fluff every time? Yeah, that's exactly what we're doing. Filling the fields with fluff every time. So that's a good way to remember FFFE. So if you ever see an IPv6 address and you see FFFE in the interface portion, you know that EUI64 was utilized to generate that unless somebody statically created an address with FFFE in it. But now we have a total of 64 bits. Now, in addition to this, there's a little adjustment that's made. And that is on the 7th bit from the left-hand side. So right now, if we count in 7 bits, so look at the 00 here on the far left-hand side. If we break that out, we end up with 0000 for the first 0 and 0000 for the second 0. So that's what we have here is all 0, 0, 0, 0, 0, 0, 0, 0. Now, what we do with the 7th bit is we flip it. We flip it. And then that's going to be a 1. And then you convert it all back, and you get 0, 2. So 2 in hex. Why is it 2 in hex? Because if you look at this and you break it up, where right there, these first 4 equals 0, and the latter 4 would then equal 2 in hexadecimal. So 0, 0, 1, 0 is 2 in binary, which is also 2 in hex. So as a result of that, you get 0, 2, and then the rest of the address. So this flipping is typically, well, this flipping's done to ensure that it's unique. But you'll see here that 1 means universally unique, 0 means locally unique. What you need to realize is that the majority of MAC addresses that you're going to find in this world always have the 7th bit set to 0 by default. When the IEEE hands out MAC addresses to the various organizations, you will find that the 7th bit, the majority, it's 0. It's the way they do it. And as a result of that, anytime you do the conversion here, you flip that 0 to a 1, and as a result of that, you get your EUI64 address. It's just all part of the process to ensure that we have those unique values. So as a result of this flipping, you end up with a total interface portion now of 029027FFFE17FC0F. So that is how the router now says, all right, so what is my address? My address is going to be a combination of this plus that EUI64 process of taking the MAC address of Ethernet 0/0, filling the field with fluff every time and flipping the 7th bit from the left. And then when we look at the output of show IPv6 interface brief, we're going to see 2001 0db8 0:1 followed by 029027FFFE17FC0F as the interface portion of that particular address.